Hi, I'm Elena Sparrow, and I'm the Education Outreach Director at the International Arctic Research Center at the University of Alaska Fairbanks. I'm also the lead of the NASA project Arctic and Earth STEM Integrating Globe and NASA. We want you to be engaged in our frost tube protocol. And as you can see in these fields, you can place your frost tube in different places, whether it's tilled, untilled, or in forested areas. And we're going to be in alfalfa field. And we are at the Fairbanks Experiment Farm.
This is Christi speaking. Here we see Dr. Kenji Yoshikawa, who will show us how to make and install a frost tube. You can see that there's a PVC pipe, and he is going to plug the end of the pipe. He'll wear some gloves because the epoxy has to be mixed and is a chemical that you need to protect yourself. So you can see that he is mixing it very well. And then he's got this plug.
Okay, good morning. My name is Kenji Yoshikawa. I'm professor at the University of Alaska Fairbanks. So I tried to show you about how to install the frost tube. We're just pounding for the metal stick.
There are weather shelter right here, and it's important to know your local area. And you can have a choice of different land cover and fields for installing your frost tube, depending on where you are.
So once I hit the ground, then we put the PVC pipe. Pipe need a bottom with the closed like this. So typically the ground freezing in the winter time, like eastern United States, typically 10 to 15 centimeters, this much. Okay, so once I put in the PVC pipe, we need to put in the clear tube for looking at the frost tube itself.
Depending on where you are at, the depth of frost tube that you install would be deep or shallow. Educators and students should know their area. Local cities and towns have codes for how deep to install the pipes. This is based on historical frost depth data.
Then we need to shield both sides for no leaking. And gas burner is great, but you can use even no windy day. So this is the depth of the height of the PVC pipe. We just marked on this. Marked for the ground surface point in 0. Then start from here, we measure the frost depths.
It is important for data quality. It's important that the ground surface is marked properly, because when the frost tube is pulled out to start reading the depth of freezing, then if you don't have that line of where the ground surface starts, then your data quality won't be good. And so this is Kenji marking the surface and then the increments.
Okay, let's summarize. We have installed the frost tube today. Depth of the frost tube now we know because we marked from here. And depth of freezing, depth of the tube is 102 centimeters. Okay, then pipe is above ground, 108 centimeters.
I'm Christi Buffington, and I am the Science Education Specialist at International Arctic Research Center, and I work with Dr. Elena Sparrow. So we know that Dr. Kenji Yoshikawa recorded some things on his whiteboard. You put down a depth, below and above ground. When you do your site definition form in Globe, you will enter these data. You'll put the date that the frost tube was installed, the height above the ground in centimeters, and the depth below the ground in centimeters. Globe will automatically calculate the total length of the tube. When you actually collect some measurements, you will do some data entry. Your frost tube data entry will need to have the time in UTC, Universal Time or local, and you will put the total maximum depth of freezing in centimeters. You'll also click on whether permafrost was present, absent, or usually people don't really know, so they'll say unknown. If you're in the lower 48 or in a place where you know you do not have permafrost, be sure to click absent. Also, one thing that's so great about GLOBE is data integration. Understanding frost tube data is even more important when you can compare it to other factors that are influencing it, such as the snowpack, which is measured through the GLOBE solid precipitation protocol, air temperature, and also surface temperature. These are all optional measurements that you have both on your data entry form and your form on the GLOBE website. So now that you have data, what do you do with it? You can analyze that data by first seeing what last year's International Virtual Science Symposium student Chelsea Huckbody did. She actually took on 4 different research questions for her investigation, and one of them was to explore the difference between a forested site and the farm site that you saw in the footage in the video today. She saw, you can see this figure on the right, that frost depth, froze down below the ground surface at about the same rate in both the farm and the forested site, although the farm didn't have as deep of freezing. So she collected data herself, but she also entered Dr. Kenji Yoshikawa's historical data from 2007 to 2011, hundreds and hundreds of data points that if you live in a place where you're not going to be able to install a frost tube, no worries. You can actually analyze Alaska frost tube data over several years. I'd like to introduce one of our collaborators, Dr. Elizabeth Borowkowski, Assistant Research Professor at University of New Hampshire at the Earth Systems Research Center.
So what protocols were we bundling? Well, of course, soil frost. This is actually a picture of our soil frost tubes. New Hampshire, our soil frost is not as deep, so our tube is only about 1 meter long. We have about a 1/2 meter that sticks above the ground and the other half goes below the ground. And when the material or the liquid inside freezes, this little chunk here is an ice cube, and that blue liquid down below is the dye. So we know that we have about 2.5 centimeters of soil frost in this tube. We also measured snowpack and then canopy green up. So with soil frost depth, our students helped install the tubes. This was happening after all the leaves fell. So we did this in about November here. And then we also had them do daily to weekly measurements until the soil was completely thawed.
We encourage you to join us for the Frost Tube campaign and get e-training on the GLOBE website.
And we welcome the participation of students in the International Virtual Science Symposium, especially frost tube projects wherever the soils seasonally freeze. Thank you so much.